Just think about it for a moment. A star so immense that it holds our entire solar system in its grip. A silent furnace, 93 million miles away. But its light, its warmth, well, that's the very engine of life itself. This is the story of our sun, the heart of our world, the anchor for all our planets, and really, the star that made us who we are.
So if we really want to understand our own place in the cosmos, we first have to understand the story of our star. This is its biography, a journey that spans billions of years, from a simple, swirling cloud of dust all the way to a fading ember in the deep, dark quiet of space.
And to get a sense of things, let's start with scale. I mean, the sun is so utterly dominant, so massive, that it makes up over 99.8% of everything in our solar system. Everything else, every planet, moon, asteroid, you name it, it's all just leftover cosmic dust in comparison.
And its size? It's almost impossible to wrap your head around. Picture our Earth, this tiny blue marble. Okay, now try to imagine cramming 1.3 million of them inside the sun. See? It's not just a star. It's a celestial giant that absolutely defines our solar system.
All of that incredible mass creates an incredible power. The sun's gravity is the great conductor of our cosmic neighborhood. It dictates the elegant orbits of giants like Jupiter and holds even the tiniest flecks of debris in a delicate cosmic dance. So, how did this colossal engine even come to be? Well, for that, we need to journey back in time, way back, about 4.6 billion years, to witness the birth of our star. You see, our story begins inside a vast, swirling cloud of gas and dust called a solar nebula. This was the stellar nursery, the cosmic cradle from which our sun, and yeah, our whole solar system, was about to be born.
And the whole process was kicked off by the most fundamental force in the universe, gravity. It started pulling the cloud inward on itself, which made it spin faster and faster, flattening out into a huge disk. Right at the center, all that material got packed tighter and tighter, heating up into a glowing protostar. And then, when the pressure and the temperature in that core became just unbearable, ignition. In a flash of unimaginable energy, nuclear fusion kicked in, and our sun blazed into life.
After that fiery birth, the sun settled into a long and stable middle age, which is the phase it's in right now. But don't let that word stable fool you. The sun is an incredibly dynamic and constantly changing star.
The sun is a star of just incredible extremes. Its visible surface, the part we call the photosphere, it burns at a scorching 10,000 degrees Fahrenheit. But deep down in its core, the temperature hits a staggering 27 million degrees. It's right there, in that cosmic furnace, that the sun fuses hydrogen into helium, releasing the very energy that powers all life here on Earth. And that surface is a chaotic sea of fire. You've got dark sunspots, which are these areas of intense magnetic activity, appearing and vanishing. Solar flares erupt with the force of billions of atomic bombs, and these can launch giant clouds of plasma called coronal mass ejections deep into space. All this activity creates what we call the solar wind, a constant stream of particles that flows right past our planet and travels all the way to the very edge of the solar system. And all of this energy, this light and this heat, it travels 93 million miles across the void to get to us. So the next time you feel the warmth of the sun on your skin, just remember, that light began its journey a little over 8 minutes ago.
But the sun's power is kind of a double-edged sword, right? It's both the reason we're here and also incredibly dangerous. And that presents a pretty fundamental challenge for us humans.
How do you possibly get close enough to study a star like that without being completely vaporized? We can't go ourselves, obviously, so we send robotic explorers in our place, these incredible extensions of our own curiosity, built to survive the inferno. We have launched this whole fleet of daring probes. NASA's Parker Solar Probe is right now flying through the sun's outer atmosphere, literally touching a star. The solar orbiter is snapping pictures so close, we're seeing our sun in ways no one has ever seen before. And then you have observatories like SOHO, which act as our constant watchmen, helping us predict dangerous space weather and protect all of our technology back here on Earth. These amazing missions help us understand the star we live with today. But you know what? They also help us understand its future. Because like all stars, our sun has a finite life. And now, we're going to journey 5 billion years from today to witness the beginning of the end. See, the fuel in the sun's core isn't going to last forever. And when that hydrogen runs out, the delicate balance between gravity pulling in and fusion pushing out,
it's going to be broken. The sun will enter its final dramatic phase of life, and it will begin a truly catastrophic transformation.
It's going to swell up into a red giant, a bloated, dying star, expanding to over 200 times its current size. Its outer layers will swallow Mercury, then Venus. Here on Earth, our oceans will boil away, our atmosphere will be stripped bare, and our world will be scorched into a lifeless rock. Right before it, too, is likely engulfed by the very same star that once gave it life.
After that final, violent expansion, what's left? Well, the sun's final chapter isn't one of fire and fury, but of a long, quiet fade into darkness.
That unstable red giant, it'll cast off its outer layers of gas. And for a few thousand years, this material will glow in the dark of space, forming this stunning, intricate thing called a planetary nebula, a ghostly, luminous monument to the star that used to be.
And at its heart, a final remnant will be exposed, a white dwarf. The crushed core of the sun, no bigger than Earth, but with a mass hundreds of thousands of times greater. A single teaspoon of its matter would weigh tons. This stellar corpse, no longer making any energy, will just spend trillions of years slowly cooling off, fading away into a black dwarf, all alone in the dark.
But the story doesn't really end there. The gas and the heavy elements blown away in the sun's final moments, they'll go on to enrich the cosmos. They will seed new clouds, new nebulae, that will one day collapse to form new stars and new planets. So as we look up at our sun, we have to remember, its life story is also our origin story. Its eventual death is the promise of future creation. The atoms in our bodies were forged in the hearts of stars just like it. We are, quite literally, stardust.